Most people who study World War II understand the obvious shortages: fuel, steel, rubber, manpower. But one of the most severe and least discussed shortages was fertile soil. Not land itself, but living, productive soil capable of feeding populations cut off from global trade. Across Europe and parts of Asia, governments quietly experimented with ways to force exhausted ground to produce food again. One of those methods worked so well, it outperformed traditional compost. And yet, after the war, it largely vanished from official agricultural teaching. Today, if you look through most standard histories of wartime food production, you'll barely see it mentioned. If you value careful, historical analysis that uncovers overlooked survival knowledge like this, subscribe to the Survival Record, because these forgotten details are often where the real lessons live. The method was simple in principle, but radical in effect. It involved deliberately transforming organic waste into stable, carbon-rich material before returning it to the soil. Not raw compost, not manure, something more durable, something that changed the structure of the ground itself. What wartime governments discovered was not just a fertilizer substitute, but a way to rebuild soil that had already collapsed. By the late 1930s, many European agricultural regions were already struggling. Decades of industrial farming, erosion, and monoculture had weakened soil biology. Then war severed access to imported fertilizers, particularly nitrogen and phosphate sources. Germany lost access to Chilean nitrates. Japan faced maritime blockades that limited fertilizer imports. Britain rationed agricultural inputs heavily while expanding domestic food production. The Soviet Union faced devastation across major breadbasket regions. Compost alone could not keep pace with the scale of demand. Compost requires time, stable organic inputs, and microbial balance. Wartime agriculture had none of those reliably. What military planners and agricultural ministries needed was something that worked quickly, stabilized nutrients, and functioned even in damaged soil. That pressure led to renewed interest in a material known in different places by different names: carbonized biomass, kiln char, agricultural charcoal. Today, many people call it biochar. Instead of letting plant waste fully decompose, it was partially burned under low oxygen conditions, creating porous carbon structures that could hold nutrients and water far more effectively than ordinary soil. When mixed with manure, food scraps, or even human waste, the material acted like a long-term reservoir rather than a temporary fertilizer pulse. This was not entirely new knowledge. Variations of the technique had appeared in earlier agricultural traditions. But wartime scarcity forced governments to test it systematically and aggressively. In several countries, the military became an unexpected driver of soil science. Fuel shortages created widespread charcoal production for energy and industrial use. That meant large quantities of partially carbonized organic material already existed as a byproduct. Agricultural ministries began experimenting with diverting some of this material to farmland. German agricultural planners, operating under strict autarky policies, conducted trials combining charred crop residue with slurry from livestock operations. Reports from regional farming offices noted improved moisture retention and sustained yields on marginal land, especially where conventional fertilizer inputs were minimal. In Japan, where arable land was limited and intensively cultivated, similar practices appeared in both civilian and military-controlled farming areas. Carbonized rice husks and wood residues were incorporated into soil mixtures designed to maintain productivity despite declining fertilizer access. Wartime documents emphasized durability, soil that could keep producing through repeated planting cycles without full replenishment. Britain's case was more decentralized. Under the Dig for Victory campaign, various experimental stations explored soil amendments that could stretch limited compost supplies. Some local programs tested charred plant matter in allotment systems, particularly where heavy rains leached nutrients quickly. The Soviet Union's experience was less formally documented due to wartime disruption, but scattered agronomic reports describe emergency soil treatments involving burned organic residues combined with livestock waste in regions where retreating armies had destroyed infrastructure. Across these different contexts, a pattern emerged. Soil treated with stabilized carbon retained fertility longer than soil treated with conventional compost alone. Nutrients remained available across multiple planting cycles. Moisture loss decreased. Microbial activity stabilized faster in damaged ground. This was not a miracle cure. It required labor, controlled burning, and careful mixing. But under wartime conditions, it often outperformed every alternative available. What made the method so powerful was not what it added to soil, but what it allowed soil to hold. Compost feeds soil biology, but much of its nutrient content can dissipate relatively quickly, especially under heavy rainfall or repeated harvesting. Stabilized carbon structures function differently. Their microscopic pores trap nutrients, water, and microbial colonies. Instead of a short-term boost, they create long-term storage capacity. In survival terms, this distinction matters enormously. A food system based on compost alone requires continuous organic input and time for decomposition. A system built on carbon-enriched soil retains fertility even when inputs become irregular. For populations under blockade, siege, or displacement, that difference can determine whether yields decline gradually or collapse outright. Wartime agricultural planners recognize this resilience. Some internal reports describe treated soil as self-maintaining compared to conventional plots. That description, while not scientifically precise, captured a practical reality farmers observed in the field. And yet, after the war, much of this knowledge quietly faded from mainstream agricultural practice. The reasons were not mysterious, but they were complex. Post-war reconstruction prioritized speed, scale, and industrial efficiency. Synthetic fertilizers, especially nitrogen produced through the Haber-Bosch process, offered immediate, measurable yield increases without requiring labor-intensive carbonization processes. Governments rebuilding shattered economies favored centralized production and standardized inputs. Chemical fertilizers could be manufactured, transported, and applied with predictable results across large agricultural systems. Char-based soil building was slower, more localized, and harder to regulate. There were also public health concerns. Some wartime soil programs had incorporated waste streams, including human waste, that post-war sanitation reforms aimed to eliminate from food production systems. Even when carbonization neutralized many risks, the association created political resistance. In addition, agricultural education increasingly aligned with industrial agronomy. Soil was treated less as a living ecosystem to be rebuilt, and more as a substrate to be supplemented with measurable chemical inputs. Over time, the wartime soil stabilization approach was not formally banned in most places. It was simply deprioritized, underfunded, and gradually excluded from mainstream teaching. What remained was a historical gap between emergency knowledge and peacetime policy. Farmers who had used the method during wartime often remembered its effectiveness, but institutional memory shifted elsewhere. Agricultural science moved toward yield maximization through external inputs rather than resilience through structural soil rebuilding. This shift influenced global food systems for decades. Industrial fertilizer dependence expanded rapidly. Soil degradation, ironically, became a long-term consequence in many intensively farmed regions. Only late in the 20th century did renewed interest in carbon-rich soil amendments begin to reappear, often framed as an environmental innovation rather than a rediscovered survival strategy. For survivalists and historians alike, the deeper lesson lies in why the method emerged when it did. It was not invented out of curiosity, it was rediscovered under pressure. When supply chains fractured, When imports vanished when soil itself began failing, governments turned to techniques that stabilize production rather than maximizing output. This distinction mirrors a broader pattern in wartime decision-making. Systems built for efficiency often fail under disruption. Systems built for resilience endure even when inputs fluctuate. The carbon-enriched soil strategy was, at its core, a resilience technology. It reduced dependence on continuous supply. It converted waste into structural fertility. It extended productivity across uncertain conditions. Those priorities make sense in war. They also make sense anywhere long-term stability matters more than short-term yield. Understanding this history changes how we interpret wartime agriculture itself. Victory gardens are often remembered as symbols of civic participation. Rationing is remembered as an economic policy, but beneath those visible programs were technical experiments aimed at preserving the biological foundation of food production. Soil was not just a resource, it was infrastructure. And like any infrastructure under stress, it required repair strategies that could function when conventional systems failed. Some of those strategies were temporary, some were forgotten, but their existence reveals how seriously wartime planners understood the fragility of agricultural systems. Remembering these overlooked survival innovations matters because they reveal how knowledge is shaped by crisis. What societies teach in stable times often reflects convenience, scale, and economic structure. What they rediscover in unstable times reflects necessity. The gap between those two knowledge systems is where many forgotten techniques live. The so-called banned soil method was never truly erased. It was sidelined by a world that believed supply chains would remain stable indefinitely. History repeatedly shows that assumption is fragile. For anyone interested in preparedness, resilience, or the long arc of 20th century conflict, the lesson is straightforward. War does not just change borders or governments, it changes how people understand the ground beneath their feet and what it takes to keep that ground alive. If you value learning the parts of history that rarely make it into textbooks but shape survival knowledge in profound ways, subscribe to the Survival Record and share this video with others who believe the overlooked details of history are often the most important ones to understand.